Today we will do chapter 2 of science class 10th, acid, base and salt. Introduction. Elements combine to form numerous compounds. Many elements, when they combine, they form compounds. On the basis of their chemical properties, compounds can be classified as number 1 acids, number 2 base, number 3 salt. Acid, base and salt in laboratory. How we classify acid, base and salt in the laboratory? There are some indicators. Indicators tell us whether a substance is acidic or basic in nature by the change in color. Common indicators are: number 1, an acid turns blue litmus red and a base turns red litmus blue. Number 2, methyl orange indicator. It gives red color in an acidic medium and give a yellow color in basic medium. Number 3, phenolphthalein. Phenolphthalein is a colorless in an acidic solution and gives a pink color in basic solution. So we can check whether the substance is acid or base with the help of these common 3 indicators. Now, what are olfactory indicators? Those substances whose odor change in acidic or basic media are called olfactory indicators. Example: onion, vanilla, clove oil. Number 2, if we add sodium hydroxide solution to a cloth strip treatment with onion, the smell of the onion is not detected. An acidic solution does not eliminate the smell of the onion. Now we study reactions of acid, base with metal. Acid, when react with metal, they produce salt by displacing hydrogen. For example, when dilute sulfuric acid react with metal zinc, it gives sulfuric zinc sulfate and evolution of hydrogen gas. Reaction is zinc plus sulfuric acid, dilute sulfuric acid. They form zinc sulfate and hydrogen gases evolve. Number 2, when zinc is the only metal which reacts with sodium hydroxide and they form sodium zincate and there is a release of hydrogen gas. Zinc plus sodium hydroxide, it gives sodium zincate and hydrogen gases evolved. Acids, when acid react with metal carbonates or bicarbonates, they form salt and water with the evolution of carbon dioxide gas. For example, when we take hydrochloric acid and it react with sodium carbonate, they form sodium chloride and water and the release of carbon dioxide gas occurs. Here Na2CO3 is a hydrochloric acid. Na2CO3 is sodium carbonate. When it reacts with hydrochloric acid, it gives sodium chloride, CO2 gas and water is released. Similarly, when sodium bicarbonate also react with hydrochloric acid, it forms sodium chloride and water with the release of carbon dioxide gas. As you can see here, NaHCO3 plus HCl gives NaCl, CO2 and H2O. What is neutralization reaction? The reaction between acid and base to form salt and water is called neutralization reaction. Example: hydrochloric acid, when react with sodium hydroxide, it form sodium chloride and water. Reaction of metallic oxide with acid. When acid react with metal oxide, they form salt and water. Example: copper oxide, a black metal oxide, when react with dilute hydrochloric acid, it form blue-green color copper chloride and water is released here. Next, reaction of non-metallic oxide with base. Base, when react with non-metallic oxide, they form salt and water. For example, calcium hydroxide, when react with non-metallic oxides, like carbon dioxide, it forms calcium carbonate, salt, and water is released. Acid and base in water, how they react with water. An acid is a substance which dissociate when dissolved in water to release hydrogen ions. Example, an aqueous solution of hydrochloric acid dissociate to form hydrogen ions. Since hydrogen ions do not exist as H plus ion in the solution, they combine with polar water molecules to form hydronium ion. Here HCl gives H plus and Cl minus, and H plus plus HO2 gives H3O plus, which is hydronium ion. The presence of hydrogen ion in hydrochloric acid solution make it behave like an acid. Next, bases. Bases is a substance which dissolve in water to produce hydroxide ions, OH minus ions. Bases are soluble in water, so they are called alkalis. Example, sodium hydroxide. When dissolved in water, they produce hydroxide and sodium ions. The presence of hydroxide ion in the sodium hydroxide solution make it behave like a base. pH scale. pH of a solution. pH of a solution is a negative logarithm to the base of 10 of the hydrogen ion concentration expressed in mole per liter. pH is equals to minus log of 10 H plus. For neutral solution, pH is 7. When pH is less than 7, the medium is acidic. When pH is more than 7, the substance is base, basic. pH scale. It is a scale showing the relative strength of the acid and alkalis. The normal pH scale ranges from 0 to 14. 7 means neutral, less than 7 means acidity increase, greater than 7 means basicity increases. Universal indicators. In case of colorless liquid, the accurate pH can be obtained by adding a universal indicator. It is a mixture of several indicators and show different colors at different concentration of hydrogen ion in a solution. Example, universal indicator produce green color in neutral solution when pH is equal to 7. The color changes from blue to violet as pH increase from 7 to 14. The color changes from yellow to pink and then to red as pH decrease from 7 to 1. What is the importance of pH in everyday life? pH change and survival of the animals. Our body works well within a narrow pH range of 7 to 7.8. When the pH of rainwater increase less than 5.6, it is known as acid rain. When the acid rain flows into the river, it lowers the pH of the river water, make the survival of aquatic life very difficult. pH in our digestive system. Our stomach produces hydrochloric acid which help in the digestion of food without harming the stomach. Next, sometimes excess acid is produced in the stomach which cause indigestion. Number 3, to get rid of this pain, bases called antacids are used, as we used ENO when we have digestion problems. Antacids are the group of mild bases which react with the excess of acid and neutralize it. ENO is the example of it. Commonly used antacids are magnesium hydroxide MgOH2 and sodium bicarbonate NaHCO3. pH change, cause of tooth decay. Tooth decay start when the pH in the mouth fall below 5.5. Tooth enamel is made up of calcium phosphate and which is the hardest substance in the body. It is insoluble in water but get corroded when pH in the mouth fall below 5.5. The bacteria present in the mouth produce acid due to degradation of sugar and food particles after eating. Hence, to prevent tooth decay, the mouth should be rinsed after eating food and toothpaste, which are basic, should be used cleaning teeth to neutralize the excess of acid. Now, salt have same positive ion are said to be belong to family of salts. pH of salt. Salt of strong acid and strong base are neutral with pH value of 7. For example, NaCl, Na2SO4. Salt of strong acid and weak base are acidic with a pH value of less than 7. For example, ammonium chloride solution has pH value of 6. Salt of weak acid and strong base are basic with pH value of more than 7. For example, sodium carbonate solution has a pH value of 9. Common salt, chemical name is sodium chloride. Common salt is a neutral salt and can be prepared in the laboratory by the reaction of sodium hydroxide and hydrochloric acid. When NaOH reacts with HCl, it gives NaCl and H2O. It is important raw material for product of daily use such as NaOH, baking soda, washing soda and bleaching powder. Now what is sodium hydroxide? Sodium hydroxide is produced by electrolysis of aqueous solution of the sodium chloride called the brine. The process is called the Chlor-alkali process because the product form chlor for chlorine and alkali for the sodium hydroxide. Here 2 NaCl when reacted with 2 H2O it gives 2 NaOH, H2O and Cl. Bleaching powder. Bleaching powder is manufactured from chlorine gas. It is produced by action of chlorine on dry slaked lime CaOH2. CaOH2 plus Cl gives CaOCl2 and H2O. CaOCl2 is bleaching powder. Uses for bleaching cotton and linen in the textile industry and for bleaching wood pulp in the paper industry. It is used for disinfecting drinking water to make it free from germs. Number 2. Baking soda. Chemical formula is NaHCO3. It is produced on a large scale by treating cold and concentrated solution of sodium chloride, brine with ammonia and carbon dioxide. NaCl react with H2O and CO2 and NH3. It gives NH4 Cl plus NaHCO3. On heating, it decomposes to give sodium carbonate with evolution of carbon dioxide. 2 NaHCO3 when heated, it gives Na2CO3 plus H2O plus CO2. Uses. It is used as an antacid to treat acidity in the stomach. It is used to make baking powder which is used in preparation of cake, bread, etc. It is used in soda, acid, fire extinguisher, washing soda. Chemical name Na2CO3.10H2O. Sodium hydroxide carbonate, hydrogen carbonate. On heating, decomposed to give sodium carbonate with the release of hydrogen gas. Recrystallization of sodium carbonate produce washing soda. 2 NaHCO3 and when heated, it gives Na2CO3 plus H2O plus CO2. When Na2CO3 plus 10H2O combine, they gives Na2CO3 plus 10H2O. Uses. It is used in glass, soap and paper industry. Employed in the manufacture of sodium carbonate such as borax. Water of crystallization. Water molecule which form a part of structure of the crystal are known as water of crystallization. The salt which contain water of crystallization are called hydrated salts. Every hydrated salt has a fixed number of molecule of crystallization in one formula unit. For example, CuSO4.5H2O, Na2CO3.10H2O, CaSO4.5H2O and FeSO4.7H2O. Copper sulfate crystals are blue in color and on heating strongly they lose all the water of crystallization and form anhydrous copper sulfate which is white. On adding water to anhydrous copper sulfate, it gives hydrated and turns blue. Reactions. CuSO4.5H2O when heated, it gives CuSO4 plus 5H2O. When CuSO4 plus 5H2O again heated, it gives CuSO4.5H2O. Now plaster of Paris. Plaster of Paris is prepared by heating gypsum at 373 Kelvin. On heating, it loses water molecules and becomes calcium sulfate hemihydrate. The formula of calcium sulfate hemihydrate is CaSO4.5H2O which is called plaster of Paris. Gypsum CaSO4.H2O. When heated, it gives plaster of Paris whose formula is CaSO4.5H2O plus 1.5 H2O is released. Uses. It is used in hospital as plaster For supporting fractured bone in the right position, it is used as fireproofing material. Thank you very much.